Alright, geometry. So I just wanted to go over every single question on this practice test with you guys because they're not going to come up exactly tomorrow, but there are going to be some very similar questions that you're going to have to deal with. So let's start with the first one. I'm just going to go through every single one, and in this YouTube video, I'll probably try to do like the little separate links in the bio here, so you can skip to whichever question you need help with. All right, so question one. Let's see. I have this angle here is 54. And I can see that, it forms this whole arc here. That 54 is across from this arc BD. So I have that. And I can also see that this angle is also across from that exact same arc. And we talked in the notes about how if two angles are across from the exact same arc, then they have to be congruent. So the measure of angle DFB, so this one up here, also has to be 54 degrees. So this is 54. 54. And then I want the measure of angle BCD. So that would be this angle right here. So let me see, I'm going to hide some of these lines. I have this quadrilateral here, this quadrilateral EDCB, I guess. I'll try to outline that, or you know what, I'll just highlight it. Yeah, this quadrilateral. I have this quadrilateral, and that's inscribed because all the angles are on that circle. And we know that two angles that are across from each other in the same inscribed quadrilateral have to be supplementary, which means that the measure of angle E, 54, plus the measure of angle C, which we don't know, has to equal 180. So I can just do 54 plus C equals 180, subtract 54 from both sides to get that measure of angle BCD there, has to be 126 degrees. So that's how to do problem number one. Problem number two. A circle has a circumference of 14 pi miles squared. What is the radius of the circle? Actually, that shouldn't say squared, that should just be miles. Circumference is not squared. But what is the radius of the circle? So our formula for circumference is going to be this circumference equals 2 pi r. So if I know the circumference is 14 pi equals 2 pi r, we just need to solve for r. Divide both sides by pi, that just cancels out the pi on both sides here. So that's gone, that's gone. 14 equals 2r. Divide both sides by 2, and r equals 7. So our radius here is 7. That's what we want to define for part A. For part B, I want to find the area of the circle. So area is going to be pi r squared. We know that the r is 7. We just solved that. So area equals pi times 7 squared. 7 squared is 49, so equals 49 pi. And on this problem, you are more than welcome to leave it as just 49 pi. You don't have to simplify that at all. You can just leave it as is. Or you can type it in the calculator, which I'm doing right now. So I'm getting 153.94. So equals 153.94, and this was in miles squared. So that's my area. All right, so on this one, pay attention to whether you're given the circumference of the area and what you want to work backwards from, so which formula you're working backwards from, and then go from there. Pretty straightforward. All right, problem number 3. Write an equation for the given circle. So to write an equation for a circle, we need to know the radius, we need to know the center. So looking at this graph, it looks like my center is right about here, which just by looking at it seems right. And that is the point 2, -2. So that's my HK. I'll make that more H-like, HK. All right, and the formula of a circle is always going to be that x minus h squared plus y minus k squared equals r squared. So I need to know my r also. I need to know my radius. So I just need to pick that center and then just count out in any direction. Doesn't matter which direction. So I can go 1, 2, 3, 4, 5 as my radius. So count 5 units there. So the radius is 5. And that's my HK. Now I just need to plug it in. So I have x minus h, so x minus 2 squared plus y minus k, so y minus -2, or just y plus 2 squared equals r squared. And since r is 5, 5 squared is 25. And that's the equation of the circle. All right, problem number 4. So quadrilateral ABCD is circumscribed about the circles shown, and E, F, G, and H are all points of tangency. Given the measurements, find the perimeter of quadrilateral ABCD. So we know this entire length is 12.7, this entire length is 7.4, just that part right there is 3, and just this part right here is 9. So if they're tangent to the same circle from the same point, outside point, then we know that they have to be congruent, which means that if HD here is 9, GD here is also 9. And if this entire distance, CD, is 12.7, I can do 9 minus, or 12.7 minus 9 to get to this point. This part right here has to be 3.7. So CG is 3.7. And if that's 3.7, then this right here is also 3.7 because it has to be the same distance from any point of tangency. So these two have to be the same thing. These two have to be the same thing. These two up here are going to be the same thing. So to find what FB is, I'm going to do 7.4, that entire distance, minus 3.7. And it's actually 3.7 again. So this is also 3.7. And if that's 3.7, this is 3.7. And if this AE is 3, then AH is 3. So to find the perimeter, I already know two sides. I know BC and I know CD. Let's see. AB is going to be 3.7 plus 3, which is 6.7. And AD is going to be 3 plus 9, which is 12. So if I want my perimeter is going to equal, let's just go out of all those sides, 6.7 plus 7.4 plus 12.7 plus 12. And if you do that on a calculator, you should get that the perimeter is going to be 38.8. 38.8 as our answer there. All right, so that's how to find the perimeter of that circumscribed quadrilateral. All right, number 5. Using the diagram below, determine whether it is a radius, chord, secant, tangent, or diameter. All right, QR only goes halfway through radius. I'll just put R for radius. PT, that goes through and then it goes out some. So if it goes outside the circle, that is going to be a secant. If it goes like through the circle and outside the circle, and it touches that circle at 2 different points, U and T, and it keeps going, so that's a secant there. Oh, since I wrote out secant, I'll write out radius, whatever. All right, RS. RS goes halfway through. That's a radius. PQ. PQ only touches the circle at one point, that point Q. It keeps going in both directions. So that is a tangent. If it only touches the circle once, it's a tangent. TS. Okay, so that's just a segment here. It does not go through the middle of the circle. It's inside the circle, but not through the exact center. It doesn't go through R. So that is just going to be a chord there. QS, that goes through the center, so that's the diameter. And then UQ, that's another chord. So there we go. Radius, secant, radius. Radius, secant, radius. Tangent, chord, diameter, chord. All right. Number 6. In circle A, segments BD and CD are tangents. Determine which of the following relationships are true. Select all that apply. All right, so we talked about how if a segment is tangent to a circle, it's going to form a right angle. So that means this is a right angle and this is a right angle. So that means B is true. Measure of angle B is 90 degrees because it's a right angle. Quadrilateral ABCD is a kite. Well, we know that CA and BA are the same measurement because they're both radii of that same circle. We also know, so I can say that that's congruent to that. We can say that these two are congruent because they're both tangent to the same circle from the same point. So if I have two pairs of consecutive congruent sides, then yes, this is a kite. Measure of angle A congruent to measure of angle D. No, we don't know that. It could be true, but we don't know that. Measure of angle D plus the measure of arc CB. So the measure of angle D plus the measure of arc CB. So arc CB is like this arc equals 180. And that's just a property that we talked about in the notes, that if we have that angle that's tangent and then it forms that minor arc, they have to be supplementary. So this one is true. D is true. And then we have a measure of angle A equals 90. That's not true. Could be, but not necessarily. So there we go. A, B, and D for number 6. All right, number 7. In the diagram below, the length of arc BC is 7 centimeters. So that means the arc here, let's see, the arc is 7. The measure of that arc is 97 there, but this length is 7. Find the length of the radius, round your answer to the nearest hundredth. Okay, so what I'm going to do, I'm going to use my arc length formula because this is the length of that arc. So arc length formula, I'll rewrite it here. Arc length equals x over 360 times 2 pi r. We want to figure out what r is. We know the arc length is 7, and we know x is 97. So it's going to be 7 equals 97 over 360 times 2 pi r. I just need to solve for r. So I just have a bunch of numbers over here with this r. So what I'm going to do is I'm just going to turn that into one big decimal. So I'm doing in my calculator right now 97 divided by 360 times 2 times pi. And I'm getting 1.693. I'm just taking that out to an extra decimal place just for specificity. So equals 1.693 r, because I turned basically all of this into one big decimal there. And I got 1.693. So now, to get rid of that 1.693, just divide both sides by it. Divide by 1.693, divide by 1.693. 7 divided by 1.693 in my calculator is 4.13. And that's all we needed to find. That's our radius, 4.13. All right, number 8. In the diagram below, Wx equals 12, so this is 12, and Wy equals 8. What is the length of YZ? Okay, so we have an intersecting tangent, that Wx, with a secant, Wz. We want to figure out the length of Yz. So when we have a tangent intersecting a secant, the formula was going to be the tangent squared equals the outside part of the secant times the entire length. So the entire length of this secant, and I'll just call YZ, I'll call that x, even though x is already a variable in this diagram, whatever. So this entire length here is going to be x plus 8. So I want to do my tangent squared, so 12 squared, equals the outer part times the entire length. So 12 squared is 144, and then I want to distribute this 8, so equals 8x plus 64. Subtract 64 from both sides, 8x equals 80, and divide both sides by 8 to get x is going to be 10 here. Or, yz is 10. Yz is 10. And that's our answer. That's all we had to find. On tomorrow's test, or Thursday's test, it is not going to be this exact problem. I think it's going to be, the two intersecting chords inside the circle, and you just got to be able to find part of that. So, just a heads up. All right. Let's see. Number 9, find the length of arc NM. So NM is, I'll highlight it here, NM is this part here. So I'm finding that. There's a couple different ways I could do this. One thing I could do, I see this 108-degree angle here, and if I can find, or I can use that 108 to find like this whole thing, this whole arc here. No, not that whole arc, just this part up to the L, yeah. So arc NKL, because it's across from it. So I can do 108 times 2, and that'll tell me this whole thing. add that to 31, and then subtract that entire thing from 360 to get the remainder. Or what I did when I solved this the first time was I see this inscribed quadrilateral with this angle M is 108. Angle K is across from it. And with inscribed quadrilaterals, as I said before, they have to add up to 180. So I do 180 minus 108 to get this angle here is 72 degrees. And we know that the arc has to be half or twice the angle. So that means I can do this angle formed, or this arc formed by this angle has to be 2 times that 72. So 2 times 72 is going to be 144. So this whole orange arc is 144 degrees. And I just need to find this green part now. So I just need to subtract that 31. So 144 minus 31 is going to be 113 degrees as my answer. So the measure, or the length of arc NM, actually it should say measure, not length. So I need to go back and fix that, but is 113 degrees. All right, question number 10. Evan is trying to graph the circle given by the equation x minus 8 squared plus y plus 5 squared equals 16. He puts the center of the circle at 8, 5 and goes out 8 units in any direction to draw the rest of his circle. Did he graph it correctly? Why or why not? Okay, so given this equation, we know that it should be x minus h, which means that 8 is h, plus y minus k, which means that negative 5 is k because it's y minus k, equals r squared, which means r should be 4. So the square root of 16 is 4. So he put his center at 8, 5, but our center should actually be at 8, negative 5. And then the radius should be 4, which means he did not graph this correctly because his center should have been at 8, negative 5, not 8, positive 5. And if the radius was 4, he should have gone out in 4 units in any direction. And I'm not going to write this out like verbally, but you know, as long as you express that somehow, just say, no, he's wrong because it should have been negative 5 and it should have been 4 instead of 8 and positive 5, then you'll be fine. All right, number 11. Given circle P below with the measure of angle ACD is 36 and measure of arc BC is 110, find each of the following measures. All right, so on this diagram, I have this 36-degree angle, and it forms this arc here, this arc AD, which means that this arc is twice the angle because that's an inscribed angle. So 36 times 2 gives me 72 for this arc here. So measure of arc AD is 72. All right, so now I have this arc, this 72-degree arc, and it forms that angle that we've already identified, as well as this angle here. So it forms both those angles because two angles form the exact same arc there, which means those two angles have to be congruent, which means that this angle, ABD, I think it is, yeah, ABD, is also 36. So equals 36 there. All right, let's see, BAC. Okay, so if I want BAC, I could do, let's see, BAC is this angle here, and it forms this arc, this 110. So I just need to take half of 110 to get that inscribed angle. So half of 110 is going to be 55, which means measure of angle BAC equals 55 degrees. All right, then I have CDB. So CDB is this angle here, and that forms that exact same arc, that exact same 110-degree arc as, what was it, BAC did? Or, yeah, BAC, which means that this is also 55. All right, so from here, what can I do? I see that this CA, that segment there, is a diameter, meaning that this arc, CBA, is a semicircle, meaning that this whole thing is going to be 180 degrees. So this whole thing is 180. I can do 180 minus that, or 180 minus the 110 there, to get that this BA is 70. So measure of arc AB equals 70 degrees. And now I want the measure of angle BCA. So BCA is going to be this angle formed here. So that's BCA. And again, that's another inscribed angle. So I just need to take half of 70 here to get that BCA is going to be 35. So BCA equals 35 degrees. Only thing I need now is measure of arc BDC. So arc BDC is going to be, starts at B, goes all the way around through D, then up to C. So that's everything but this 110. So to find the measure of arc BDC, I just need to do 360, which is the whole way around that circle, minus 110. So 360 minus 110 equals 250 degrees. So that's my answer. And that's my answers for number 11. And finally, we have number 12. I kind of hate number 12, but whatever. It's on the test, not my choice, it's the county. So the farmer sets aside the circular area for his horse with an inner fence, which we can see has the E and the C on it, and the outer fence with the D and the B on it. Unfortunately, part of it was destroyed in a landslide. The shaded sector represents the part of the horse's area that was destroyed, and I apologize that it's not really coming up as shaded on your sheets, but whatever. It is this sector here. We want to know what is the area of the entire sector that got destroyed in the landslide. So we're going to be using sector area. So my sector area formula is going to be x over 360 times pi r squared. I need to know x, I need to know r. So x is the angle measure, so x equals 89. And r, let's see, if I want this entire shaded area, well, I know that from A to C is 27, and from C to B is 11, so 27 plus 11 is going to be 38 for my radius here. So that whole distance is 38, so my r equals 38. I just need to plug this into my formula. So let's see, when I do that, sector area is going to be 89 over 360 times pi times r squared. So r is the 38, so 38 squared. I'm just plugging this in my calculator right now. 89 over 360 times pi times 38 squared equals 1,121.51 feet squared. So the whole area, this blue shaded area that got destroyed in the landslide, is 1,121.51 feet squared. All right, so now we want to find the area of the sector of the inner fence that got destroyed. So just the sector of the inner fence. So we're finding the area of this part. So only up to like EC. So for this one, it's the same angle. So X is still 89, but now my R is just 27. So that part only goes to 27. So it's going to be my sector area equals, and I'll write out my X and R again. X equals 89, R equals 27. Sector area is going to be 89 over 360 times pi times r squared, so 27 squared this time. And I'm plugging this in a calculator again. So 89 over 360 times pi times 27 squared equals 566. So 566.19 square feet. Okay, so that's how to do that. I got my first two. I got the area of this entire blue part. Then I got the area of just that yellow part there. So then I have part C. What is the area of the part that was between the inner fence and the outer fence that got destroyed? So that would be everything that's still blue here, everything that I'm about to color green. So all of this, I'm finding all of this right now. So I already know that the whole area is that 1,121 and that yellow area is 566. So that green area is just going to be everything that's left over. So that's exactly what I'm going to do here. I'm just going to do, I don't have to do any like sector area formulas for this. I just have to do 1,121.51, which is the entire thing, minus the inside part, 566.19. So when I do that in my calculator, so 1121.51 minus 566.19 equals 555.32. And this is area, so feet squared. That's my answer. All right, so I got those first three parts. Next part, he wants to spread mulch around the outside part of the destroyed area. If it takes 3 bags of mulch to cover 1 square foot of ground, how many bags of mulch will he need? Okay, so the outside part of the destroyed area is that green part there. I hate the way this is worded, but it's this green part here. So it needs to spread mulch around here, and we just calculated that the square footage of that is this 555. So it takes 3 bags to cover 1 square foot. So if there's 555 square feet, 555.32, I just need to multiply that by 3 to get my answer. So it's just going to be 555.32 times 3 equals 1,665.96. And since this is bags of mulch, I'm going to just round that up to 1,666 bags. And that's my answer here. And finally, he has enough fencing for the inner portion. So he has enough fencing to cover from E to C. He has enough fencing for that, stored somewhere, I guess. But he needs to buy more fencing for the outer portion. How many feet of fencing will he need to purchase to enclose the entire area? So he needs to get this part here. I'll do a different color for that. So he needs to get this part here, this red part. So that's just going to be the arc length formula. We just need to figure out how long or how much fence should he be purchasing to cover that part. And it looks like our R is going to be 38 again, because it would go from the center all the way out. So that is 38, not 11. I saw some people using 11 here. But it is going to be the 38, and we're using the arc length formula. Arc length formula is that x over 360 times 2 pi r. And as we said, x is still 89. R is the 38 now, and I'm just plugging this into my arc length formula. So it's going to be 89 over 360 times 2 times pi times 38. Plug it on a calculator. So 89 over 360 times 2 pi times 38. I'm getting 59.03 equals 59.03 feet of fencing. So there we go. Those are my answers to every single question on the practice test. As I said, tomorrow's test will look very similar. Not exactly the same, but if you can do this stuff on here, you can do this stuff on the test. Please ask me if you have any questions. Come to my office hours, because I do have those from, I don't know what time it is. I think it's like 8:30 to 10:30 or 8 to 10 or something like that. I'll send out a Schoology message. But yeah, if you have any questions, please ask. Otherwise, there you go. Good luck.